All right, so our song this time is She's a Beauty by the Tubes. Okay. Our next example, we're going to be writing the inequality from the graph. So the first thing that I notice is that there is a piece in the center where they don't meet. This looks to me like the or inequality that we just graphed. So I'm thinking we have an or statement. And I am just going to write the inequality from the left and from the right. So here I'm noticing that we are at -1 and we're less than. So x is less than or equal to -1. And off to the right here, we've got x is greater than, but not equal to, 6. And you can make your inequalities a little bit more fancy if you want to. You could maybe multiply both sides by 2, add 3 over here to make it look a little bit more complicated. But any variation where when you solve it, you get x is less than or equal to -1 or x is greater than 6 will give you the same results. All right, so now we're going to take a look at the absolute values. The equations are a little bit more straightforward than the inequalities. So we, first of all, isolate the absolute value. So I'm going to add 8 to both sides. I'm going to divide both sides by 3. And once I have my absolute value isolated, I'm going to set up 2 equations, because remember, what's inside the absolute value could be negative, and then the absolute value makes it a positive 20. So we have 2 answers here. 5x equals 20, just drop the absolute values. And I never know for the equations which word is more appropriate. Both words seem to work just fine, and or 5x equals -20. So we solve each of these, and we got x equals 4 or -4. Or we could say x equals 4 and -4. Both terms work for the equations. But for the inequalities, only one term works, and we're going to have to figure out which one. So starting here with our less than inequality, first thing I'm going to do is isolate the absolute value. So multiply both sides by 3. And now what I have to think about is I need to set up a compound inequality. Is it a less than, is it an and inequality, or is it an or inequality? So what I want you to think about is, and I'm going to use a smaller number, let's just say the absolute value of x is less than 2. Let's use this as an example to see if we can figure out which word is appropriate. So start thinking about some numbers that make this inequality true. Well, 1, 0, -1, -1.9, but -2 will not make it true, and +2 will not make it true. Any numbers bigger than 2, 3 won't work, 4 won't work. Let's see, negative numbers, -3 will not work, -4 will not work. So what I'm coming up with as I'm generating this list is values in between -2 and 2, because the absolute value of those numbers are less than 2. So this looks to me, where we've got that overlap, like an and statement. So if we have a less than inequality, we will set it up when we split up our compound inequality and drop the absolute value as an and statement. Now, we have to be careful here, because what happens when we rewrite it for our negative is, think about the fact that we're multiplying our 24 by a negative, so we have to flip the inequality. So going back to the more basic example we just looked at, absolute value of x is less than 2. Thinking about the solutions we got right here, it was greater than -2. So less than 2, greater than -2. So when you set up that second inequality, you need to flip the symbol. And then you solve them like normal. So we're going to subtract 8 from both sides and divide by 4. And we subtract 8 from both sides and divide by 4. And since this was an and, we graph where they are both true. So I've got a -8 over here. And we've got a less than and a greater than, so these are open circles. And we shade in between less than 4, greater than -8.